All right, hello everyone. Just want to go over kind of horizontal vertical translations, kind of verify what you guys did here from, what was that? Exploration 1. What happens horizontally and vertically to a parent function, or for that matter, any function, when you move it up, down, left, and right. And what we looked at in the explorations, particularly exploration 1, was how to do it graphically. What we're going to do here is we're going to show you how to figure this out algebraically, which means doing a little bit of algebra, some number crunching, that type of thing. So let's get rolling here in just one quick minute. All right. So we're talking about horizontal translations first, and then we'll go to vertical translations. So if you remember, a horizontal translation is basically taking a graph and shifting it left or shifting it right. And the process of that looks like this, or I should say the definition. So let's say this, the graph of y equals f of x minus h, think of that as kind of a formula. Okay, the graph of y equals f of x minus h. We call that a horizontal translation. Okay, remember, a horizontal translation is taking a function and moving it over to the left and moving it over to the right. Okay, so we say it's a horizontal translation of y equals f of x. And we have to say h does not equal 0. Because if h does not equal 0, then these two things are the same. Now, if you remember earlier, I had mentioned something about adding and subtracting on inside. Okay, adding and subtracting on the inside. Keep that in mind right here. Okay. We're going to skip over this graph because I don't like these graphs, so just kind of cross that out. Kind of some side notes that will help you with the examples. And what happens? Let's say this. So we say y equals f of x minus h. What happens if we take something and we subtract h units? This means it's going to move right, h units. And if we have a plus in there, we're going to move it left, h units. Okay? All right, vertical translations. Vertical translations is moving things up and down. Okay, vertical. So let's talk about what that looks like, a definition of it. The graph, let's say this. Graph of f of y equals f of x plus k. F of x plus k. We say that is a vertical translation. Okay. Vertical translation of the graph. Y equals f of x. And we have to say k cannot equal 0. Okay. Now, think about what we mentioned earlier for vertical translations. This is where we add and subtract outside. Okay, add and subtract on the outside. Once again, let's skip over that graph. I don't like it. And just some other notes. So let's say we have y equals f of x plus k. Notice we're adding k, whatever that number might be, units. When we add it, k units up, units. And when I say f of x minus k, we say k units down. Okay, so keep those things in mind when we talk about vertical translations and horizontal translations. So if you have a graph, talk about horizontal, if you have a function that on the inside of the function you subtract so many units, that's going to move it to the right, and if you add so many units, that's going to move to the left inside of the parent function. And we'll talk more about this moving forward. Similarly, if we add k units on the outside, it moves it up and it moves it down. Just like we looked at, I believe, in Exploration 1. Yes, Exploration 1. Okay, Exploration 1 and Exploration 2. 1 and 2. So, alright. Let's look at this example right here. So let's say let f of x equal 2x plus 1. And write a function g whose graph is the translation. How about I get when we can see that? Alright, so we're doing example A here. Write a function g whose graph is a translation 3 units down of the graph f. So, what do we need to do? We want to move it 3 units down. So this right here. So let's go. So we know that g of x is going to equal f of x, and to move it 3 units down right there, because we're using this equation right there. Okay? But what is f of x? F of x is 2x plus 1. So what we can do now is we can say g of x, instead of writing f of x, we can substitute in 2x plus 1. So I'll substitute that in, and then minus 3. So we really didn't need to put those parentheses in there. I just used it to show the substitution. So g of x, 1 minus 3, equals 2x minus 2. Real quick, let's look at that thing graphically. So let's go to our Desmos calculator. And I just want to graph the two. Give that a second to pull up here. Come on. Guess my internet's not very good. Come on, there we go. Alright, so let me put in the first function. F of x equals 2x plus 1. And there's that function right there. And now let me put in the new one. G of x, g of x equals 2x minus 2. Notice how it is 3 units down, because look at, we got that right there, which is 0, 1, and we got that right there, which is 0, negative 2. So it goes from 0, 1 to 0, negative 2. You can see that's a shift of 3 units down. And that's what we just did algebraically, is we shifted it 3 units down. Alright, looking at the second example, write a function h whose graph is a translation 2 units to the left of the graph of f. So here's what we know. We know h of x is going to equal f of x plus 2. Now, why is that on the inside? See how it says 2 units to the left? Notice we go x plus h left, h units, h is 2 this time. So that means right there. Alright, so what's the next thing we got to do? So we got to go h of x. We have to take this x plus 2 and we have to substitute it in to the x in that function right there, function f. So that's going to look like this. 2 parentheses, we're going to replace the x with x plus 2. And we still got our plus 1 out there. Got to do the distributive property. I'm going to write things down here, and we're going to have 2x plus 4 plus 1. Do the distributive property. And that gives me h of x equals 2x plus 5. And what that should have done, what this equation will do right here, is that equation will move this function 2 units to the left. And let's see what that looks like. Alright, so we've got that one right there. Let's replace this one. H of x equals 2x plus 5. Look at right here. So, let's see here. 2x plus 5. Looks good. So what's this point right here? That's not a good point. Let's use this one. 0, 1. Notice we got 0, 1 right there. And notice that's 2, 2, 1. So no, negative 2, 1, excuse me. So notice 2 units. 2 units left. Okay. Thank you very much. And go on.